In this video, we will talk about the degrees of the relationship. As we have seen in the previous video, we had a relationship going from one entity to itself, and we said this is what we call a unary relationship. Now we will talk about 3 degrees of the relationship, but first, what is the degree of a relationship? It refers to the number of participating entity types in a relationship. So basically, how many entity types are participating in that relationship. We have unary relationship where we have only one entity type participating in the relationship. The most common one, which is the one that you will face most of the time, is the binary relationship when we have two entity types participating in that relationship. And then we have the ternary relationship where we have three entity types participating in a relationship. So let's look at each one and have some example. A unary relationship, again, is a relationship between the instances of a single entity type. So as we've seen previously, a person is married to one person, so we have a one-to-one binary relationship. So the first one right here is what we call a one-to-one, unary relationship. So one-to-one unary relationship. And this is a one-to-many unary relationship where we say an employee manages multiple employees and each employee is managed by one employee. And then we have another one-to-one relationship right here, which is unary. A team stands after another team. So you can also have some one-to-one, many-to-many unary relationship. The binary relationship is a relationship between the instances of two entity types. Again, this is going to be the most common one, the most popular. You will encounter this the most when doing your data modeling. So again, some examples here. As we've seen, the employee with parking example, which is a one-to-one binary relationship. We have product line containing multiple products, which is a one-to-many binary relationship. And we have students registering for courses where these students will register for multiple courses, and the course can be taken by multiple students. So we have a many-to-many binary relationship in that case. Now, a ternary relationship is a relationship that is simultaneous among the instances of three entity types. Now, I know that we have what looks like 4 entities in this case, but this is what we call an associative entity, which we'll cover later on. Now, this is exactly like this. So if I say, okay, this is Bart, and I have my vendor here, and I have my warehouse, then a relationship is going to be like this. This is a ternary relationship. Now, if I have something like this, let's say entity 1, and then I have entity 2, and I have somewhere here, let's say entity 3, and I have some relationship like this. Is this a ternary relationship? The answer is no, because we say it's a simultaneous relationship among the instances of the 3 entity types. Now this is one binary relationship and this is another binary relationship. So what I have in this case is actually 2 binary relationships. This is not a ternary relationship. For a ternary relationship, it has to be the same relationship and it has to have both all three entity types participating in that relationship. Now, how can we read this? It can be read multiple ways. So you can say a vendor supplies a part to a warehouse. A part is supplied to a warehouse from the vendor, and then we say the warehouse gets the parts from the vendor. Now, as for cardinality constraints, we will talk later about how to read them when you have an associative entity. But if I have this without the associative entity, now this is going to look something like this. So I will say a part is supplied to multiple warehouses by multiple vendors, and the warehouse gets multiple parts from multiple vendors, and the vendors supply multiple parts to multiple warehouses. And this is how you read it. So since I have a three-way relationship, then I will have three business rules. Okay. Now let's look at some more examples. And this example is going to show that the entity types can be related to one another in more than one way. So it's not necessarily that I have only one relationship between entities. So if I have entity 1 and I have entity 2, then I have one relationship. That's what we have seen so far. Can I have another relationship? So this is something. So this is R1 and this is R2, but then R1 is not equal to R2. So R1 is a different relationship. Can this happen? The answer is yes, and this is one example. So if I say the employee works in a department, but then a department is also managed by an employee. So I have two types of relationships between employee and department. The employee can work in the department, and the employee can be the manager of the department. So these are two different relationships, but between the same entity types, which is totally fine. We can have more than one relationship between the same entity types. Let's look at a bigger ERD example, and let's see how we can draw the whole picture. So when I say a shipping company relies on an information system where shipped items are the main part of the company's information system. Shipped items are characterized by item number, which is unique, weight, dimensions, insurance amount, destination, and delivery date. Shipped items are received at a single retail center. Retail centers are characterized by their type, unique ID, and address. Shipped items make their way to their destination via one or more standard transportation event. These transportation events are characterized by a unique schedule number, a type, for example, flight or truck, and a delivery route. Then what we want to do is to draw the ERD for this shipping company. Now before we draw the ERD has three main parts: entities, attributes, and relationships. So we have to extract all entities, all attributes, all relationships, and then with the relationships we have to extract the cardinality, and then we can draw our ERD. Now let's first start by extracting our entities. It says a shipping company relies on an information system where shipped items are the main part of the company's information system. Can we get any entities from this? When we say a shipping company, this is one instance, so it cannot be an entity. An information system cannot be an entity. Shipped items, so we have shipped items, so this is one entity because we will have multiple items, and as we see right here in the second sentence, shipped items are characterized by so and so. From the definition of an entity, if we have multiple instances and they have multiple characteristics to be stored in the system, then this is an entity. So we got one entity. Now these are received at a single retail center, so we don't know yet if this is going to be just one retail center. So this doesn't mean we only have single retail center, or does it mean cardinality? So let's leave this for now. Now the next one says retail centers are characterized by their type, unique ID, and address. So if I look here, okay, retail centers. So this is going to be an entity instance. Now this makes sense to be another entity. So I'll have retail center as my second entity. Now shipped items make their way to their destination via one or more standard transportation event. So since I had one or more, this is telling me there is a relationship, and I know this is an entity because I said this is my first entity. So this has to be another entity right here. And to make sure, when I read this, these transportation events are characterized by a unique ID. So I have multiple transportation events and they have multiple characteristics. This tells me that this indeed is an entity. Now let's choose another color. Let's go blue for attributes right now. Now I'm done extracting all entities. Now my next step is, so this is done. My next step is to extract attributes. Now let me deal with the first entity, shipped items. So these are characterized by item number, which is unique. So this is going to be my primary key. And then I have weight, which is one attribute, dimension, insurance amount, destination, and delivery date. These are all attributes of entity 1. Shipped items are received at a single retail center. This doesn't tell me any attribute. Retail centers are characterized by their type, unique ID, and address. So this is my primary key, which is the unique ID, and these are the attributes of my second entity. Shipped items make their way to their destination using this. This doesn't tell me any attributes. These transportation events are characterized by a unique schedule number. So this is going to be my primary key, which is the schedule number, type, and a delivery route, which is the third attribute of entity 3. Okay, now let me choose another pink color for our relationships. Now let me just read it back again and extract the relationships. So shipping company relies on information system. We don't have any relationship here. Shipped items are characterized by. So characterized by, although it may be read as something that's very close to a relationship, but this is telling me what are the attributes, so this is not a relationship. And then dimension here, shipped items are received at a single retail center. So I have a relationship from shipped items, which is E1, to which one is, yeah, to E2, which is retail center. So I have some kind of relationship between those two. And then shipped items are received as single retail center. So E2 is single, and since I said shipped items, that means these are many items that are going to be received at that retail center. Make their way using one or more standard transportation events. So this is going to tell me that shipped items, I have another relationship here between entity 1, which is shipped items, and between entity 3, which is transportation event. So what is the cardinality of this? Again, it looks exactly like the previous one. Shipped items will make their way, so it is going to be E3, which is transportation event, and we have multiple items here on this side, so this is E1. So these are what I need. I need those three entities and those attributes, and then I need my relationships. Now, there is one thing that I need to take into account, which is when I look at something like address, I know this example doesn't specify it, so I can go ahead and make it just an atomic attribute. But if I want to be more thorough, then what I need to do is to make this uh, a composite attribute. So let's look at how the ERD is going to look. So this is going to be my ERD, 1, 2, 3 entities, 2 relationships, and then I have the retail centers, the attributes for retail center, transportation, and shipped items. And this is a typical example of what you might get as a question to extract all of those things, which is entities, attributes, and relationships, and then draw your ERD accordingly.